Hello everybody, this is Dr. Christopher White, and in today's video we're going to be doing exercise 1 from Interpreting Earth History by Ritter and Petersen. Okay, so exercise 1 starts on page 1. I'm sure you're shocked by that. So the thing about exercise number 1 is exercise number 1 deals with relative dating and unconformities. Now page 1, 2, 3, 4, 5, 6, 7 and 8 all contain very helpful information, so don't just skip past them. Please take some time, read them, because if you do read them, they are going to make your life so much easier when it actually comes to doing the lab. It's that simple. Take a bit of time to read them. This becomes a lot easier. You end up with a nice high mark. Simple. So the part A of exercise number 1 is relatively straightforward. I'm sure you remember these diagrams from when you took physical geology. So they're the standard block diagram, and the aim is to try and put the rocks in a chronological sequence from oldest to youngest. Now remember, obviously in order to do this you have to take into account things like superposition, cross-cutting relationships, principle of inclusions, unconformities. So let's go and have a look. Let's have a look at this one here. Alright, now we can obviously see that these layers have been tilted. Obviously principle of original horizontality says they would have been horizontal sheets originally. So initially they would have started off in that position, but they've been tilted later on. So obviously that tells us straight away that layers F and B, which are horizontal, must therefore be older. Because if they were the same age as these 4 layers down here, they too would be tilted, but they're not. So they must be younger. Alright, so in terms of working out the order of these 4 layers here, of course the principle of superposition is king. Oldest at bottom, youngest at top. So you're going to work your way through these 4. And then we can quite clearly see here we have ourselves a lovely angular unconformity. We have dipping rocks below the unconformity and horizontal rocks above the unconformity. Classic angular unconformity. So clearly D must straddle the space between these tilted layers and these horizontal layers. And then once again, as you go to F and B, obviously the principle of superposition is king. In terms of this diagram here, principle of inclusions, that's really going to help you out there. Now, this diagram here is of course by far and away the most complicated. So you can see we have multiple different layers. So in this one we've got to worry about the principle of cross-cutting relationships, especially is going to be very important to us. So we can see that G and D obviously cross-cut all rock layers, so they're obviously going to be the youngest. Because remember, principle of cross-cutting relationships, essentially it says that if we take into G for account, for instance, G cuts through all layers, and therefore obviously in order to cut through those layers must have been present before G was intruded. It just makes perfect sense, doesn't it? In terms of working out the order, well, I'm not obviously going to give you too much information. Obviously these layers here, principle of superposition is going to help us there. Now let's just take a second and think about M though. Alright, when a lot of people do this diagram, they seem to put M at the start. It is not. M is not the oldest rock in this sequence. Okay, so if we look at M, we will notice that M cross-cuts all of these rocks here. Alright, so take into account the principle of cross-cutting relationships when you are noting where M falls in the sequence. Also, please bear in mind that J, well, see which layers of rock J cuts in terms of trying to work out where J falls in the sequence. Okay? Once again, if you read the paragraphs on the previous 5 or 6 pages before you even start the lab, it is going to make this question so much easier. If we turn over onto page 10, you will see there are 2 more block diagrams. This one here is extremely easy, so not going to worry about that too much. This one here is a little bit more complicated. Just a point to note, E down here in the bottom corner has lots of wiggly lines on it. That is normally a sign to suggest that E is a metamorphic rock. L, on the other hand, has randomly orientated little lines. That would suggest that L is an igneous rock. So obviously, in order for L to intrude something, E has to have been there first. So that means E obviously has to predate L. I'm just going to help you with that one. Obviously, the rest of it you can do by yourself. It's pretty obvious. Once again, principle of cross-cutting relationships, principle of original horizontality is also going to help there. Okay. All right. So part A is relatively straightforward. On to part B. So part B deals with this diagram here. You will find it at the bottom of page 11. It's a very simplified diagram of the inner gorge of the Grand Canyon in Arizona. Now, to begin with, please take note that you can see we actually have a key down here in the bottom left showing you what each of the different styles mean in terms of the layers of rock. So for instance, if it's a limestone, it's going to have a brickwork pattern. So the red wall limestone here, as you can see, has this very brickwork appearance to it. If it's a shale, a mudstone, it has this kind of very faint set of dashed lines. So the supply group up here, you can see, has lots of these very, very faint lines. In terms of if it's a sandstone, it's going to have a rather speckled appearance. So the Coconino sandstone up here is very, very spotty, it's speckled. Schists have wiggly lines, so we've got the Vishnu schist down here. And granites have these randomly orientated lines, and we can see the granite here of the Zoroaster granite. So you can see that each of these different layers has a different pattern on it, and we can refer back to the key to work out what type of rock that layer is made from. Okay, so what are the questions? Well, the questions are simply asking us very, very basic principles of relative dating and trying to relate them back to the diagram we just looked at. So for instance, what is the oldest body of rock in the Grand Canyon? Relatively simple question. So if we turn back to our diagram here, obviously the principle of superposition is going to help us work out which layer is going to be the oldest, I do apologise. Now once again, when we're down at the bottom, if it has the wiggly lines, it's a schist, it's a metamorphic rock. If it has these randomly orientated lines, it's going to be a granite, so it's an igneous rock. The granite, the igneous rock, has to intrude something. So that would obviously mean that the schist has to have been there first. Just going to, once again, just going to drive that point home just so you start to get it into your heads. So in terms of question 2, what is the oldest sedimentary layer? Okay, schists are metamorphic, granites are igneous. So for the first sedimentary layer, you're going to ignore granites, you're going to ignore schists, you're going to focus on sandstones, shales and limestones. So find essentially the youngest one of these layers. It could be a sandstone, could be a shale, could be a limestone, but one of those types of rock is going to essentially be the oldest sedimentary rock in the sequence. Then obviously what is going to be the youngest Precambrian. Please take note of that, Precambrian rock in the sequence. Well, once again, if we go back to our sequence here, you can see here are the Precambrian rocks. Which one of those is going to be the youngest? Now for each of these you're going to have to make a note of the principle of relative dating that you've used to actually decide that it's the youngest or oldest in that particular portion of the sequence. So for instance, if we go back to number 1, well, what is the oldest body of rock in the Grand Canyon? If we come and have a look, well, it's obviously got to be the Vishnu schist for 2 reasons. Number 1, it's right down at the bottom of the sequence. So the principle of superposition says it's the oldest. Number 2, we can see that the Vishnu schist is cut by the Zoroaster granite, and the Zoroaster granite is then cut by the rocks of the Precambrian here. So that would suggest that the Vishnu schist must therefore be older than both the Zoroaster granite and the rocks of the Precambrian. So essentially we can also use the principle of cross-cutting relationships to work out that Vishnu schist is going to be the oldest. So superposition and the principle of cross-cutting relationship says the Vishnu schist is going to be the oldest rock in this diagram. So these are the kind of things we're looking for. Question 4, what is the oldest Paleozoic formation? If you remember, the Paleozoic are the periods after the Precambrian. So the Paleozoic is going to be the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. All right. Obviously, once you go into the Triassic, Jurassic, Cretaceous, you're into the Mesozoic. If you'll notice, though, the rocks at the top here of the sequence are Permian in age. So obviously there are no Mesozoic rocks above it, so we don't have to worry about the Mesozoic at all. Part 5. What is the name and lithology of the youngest formation? Well, you can work that one out. Once again, principle of superposition is going to help you with that one. Number 6. What formations, plural, not singular. Oh, sorry, I'm really out of shot here, aren't I? There we go. What formations comprise the Cambrian system in the area? So, which formations are Cambrian aged? List them. Number 7. Visually trace the unconformity at the base of the Tapete sandstone. Tapete sandstone is down here, is this yellow layer. From left to right. So obviously the western side of the gorge is going to be over here. The eastern side of the gorge is going to be over here. How does the nature of the unconformity change as we go from the west to the east? So note how the unconformity at the base of the tapetes, well, what type of unconformity is it in here? Over here, sorry. And what type of unconformity do we have over here? Are they the same types of unconformity? Do they change? Once again, if you've read the paragraphs, read the part at the start of the exercise, you'll be able to work this out relatively easily. Then we come on to question number 8. So what Paleozoic systems are not represented in the Grand Canyon? So remember, Paleozoic, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. So those are the ones you're looking for. Which of those are missing? All right. Now, please take a second and make sure you take note of what's written over here. All right. Don't miss that. Number 9, briefly discuss the nature of the Devonian system in the region in terms of its regional extent, lithology, and history. Well, okay, so number 1, find the Devonian age rocks. Next, what's the regional extent? Do they form a nice layer that's continuous, or do they form bodies that are discontinuous? So, does the layer just kind of like pop up and then disappear, pop up and then disappear again? Let's see. What's the lithology? So what rock is it made from? And then finally, what's the history? Well, obviously, that one's a bit trickier. And I've got to be honest, for that one, it may be wise to just take a second and have a quick look on Google. All right? So Google the rock layer that's named on the diagram. And it's going to discuss the history of this particular layer, and that's going to make your life a lot easier. And in a lot of the time, the descriptions that you'll find on Google are extremely good, and they will explain how this layer formed, and it's going to help you to answer question number 9 here. Don't be afraid to use Google for this one, because the history is not particularly easy. Actually, it's a bit of a difficult question. If you're if you've got some university geology behind you, you'll be able to answer this question relatively easily. However, as you guys are just in the early stages of taking geology courses, this is not a particularly nice question to ask, so don't be afraid to go to Google just to give you a little bit of help. Number 10. What was occurring in the area during the Mississippian period? Alright, well, if we have a look at the diagram, what's going on during the Mississippian? Okay. So what kind of rocks are present, and what do those rocks tell us? So for instance, if it's a rock that could only form in a continental environment, well, that would clearly mean that during the Mississippian the area was above sea level. If the rock could only form in a marine environment, well, that would clearly mean during the Mississippian the area was below sea level. Question 11. What is the nature of the boundary between the red wall limestone and the supply group? Well, let's just go back to the diagram for a second. Okay. So the red wall limestone is here, it's this grey layer, and the supply group is here, it's the orange layer. So the question then becomes is what's the nature of the boundary between the two? Now, we obviously have the Mississippian and we have the Pennsylvanian, and we know that those two periods followed each other. So from that point of view, it's a continuous sequence, isn't it? Going from the Mississippian straight to the Pennsylvanian. Okay, that kind of makes sense. But we have these semicircular shapes here and here. Okay, it's called the surprise formation. Now, this is telling us that something is going on. Maybe it's not quite the normal situation that we would expect. So maybe, yes, this dates from the Mississippian, and yes, this dates to the Pennsylvanian. But don't forget, the Mississippian and the Pennsylvanian are tens of millions of years in size. Okay, that means this could represent 5 million years of the Mississippian, this could represent 5 million years of the Pennsylvanian, and there could be something like 20 million years completely missing. So you have to try and work out what these semicircular features could possibly mean, okay? And you have to think about what could possibly form one of these semicircular features. Now, once again, don't be afraid to go onto Google, all right? Google is going to help you with this. Also, don't go onto anything too heavy duty, all right? Stick to very simple websites like Wikipedia, for instance. Do not start going into publications. That's just too much information, all right? So stick to simple websites and see what it says about things like the surprise formation, all right? And what it represents and what the surprise formation is filling in. And that's going to tell you about what's actually happening as you transition between the red wall limestone and the supply group. Question 12. What is happening geologically in the Grand Canyon during the Ordovician period? Okay, well, obviously, please remember, as a geologist, the only way that we know what is happening is if we have rocks. If we have rocks, then that's great. We can look at those rocks, we can work out what's happening, and we can come up with a geologic history for that time period. If we do not have rocks, we have absolutely no idea. All right. For all we know, during that time period, the world was covered in unicorns and dragons. But if we don't have any kind of evidence, we don't know. Okay, so on to question 13. Briefly outline the geological history of the Grand Canyon from Precambrian time until now. So, head back to figure 1.7. We are essentially trying to work out what the geologic history is. Okay, so in terms of the geologic history, it's number one. What order were the rocks deposited in? Number one. Next, we need to think about at any point were layers tilted. Well, we can quite clearly see these layers down here have been tilted, haven't they? But these layers here are horizontal. That clearly means that whatever event tilted these layers has to have occurred before these horizontal layers were deposited. Because remember, if these horizontal layers were essentially as part of the same sequence we see here, they too would be tilted, but they're not. They're horizontal, therefore they must have come later. So, work out the order of the rock layers. Work out when there's been tilting. Work out when there's been erosion. And obviously erosion would turn up in this instance in the form of unconformities. Okay? In the case of Zoroaster granite, work out when that intruded in the sequence. And you're going to put this all together in essentially a chronological sequence. And now I know there's not much room here, so do it in the form of a flow chart, starting with, the oldest rock here, and then saying, right, Vishnu schist, intruded by Zoroaster granite cut, erosion, then this layer of rock was deposited, then this layer of rock was deposited, then this layer of rock was deposited, then the whole lot was tilted, then there was more erosion, etc, etc, etc. Okay, once again, not looking for huge quantities of detail here. We're just looking for you to try and get this into a nice chronological order, and we want to see that you've begun to comprehend, that the unconformities represent periods of erosion, and we want you to comprehend how when some layers are tilted and some layers are not tilted, that also helps you to work out exactly what the relative age of those layers are to each other. Then finally, question 14. Which unconformity depicted in figure 1.7 represents the greatest hiatus? Okay, so most complex and prolonged sequence of geological processes in the Grand Canyon. Okay, now this one is a tricky question. So essentially hiatus obviously means stop. So what we need to do is we need to try and work out which period on this diagram here represents the greatest stop, essentially. So these stops, of course, can be marked out in the form of unconformities. So if we have a look at the sequence, well, quite clearly we have an unconformity here between the Vishnu schist and the Bass limestone. We obviously have another unconformity here between these tilted rocks and these horizontal rocks. And we have other unconformities, disconformities in this sequence here as well, which hopefully you'll be able to pick out. Now then, of course, please bear in mind we clearly have another unconformity. It's a very modern unconformity compared to all the rest, but it is an unconformity nevertheless. Okay, now bear in mind the Permian ends, there's no Mesozoic rocks, there's no Cenozoic rocks. All right, they're missing. If any rock has been deposited during the Mesozoic or Cenozoic, it's been eroded away, it's gone, we don't know whether it's there. Don't forget there is also one more unconformity here, very modern, and it's cutting through everything. You'll have to work that one out for yourself. So this one is not a particularly nice question, but it is essentially asking us which unconformity, which feature represents the most missing time, for want of a better way of describing it. So obviously, in terms of trying to work out which unconformity represents the greatest lost time, we have a bit of a problem for some features. So for some things like the Zoroaster granite and the Vishnu schist, you're going to actually have to try and find an age for them because they're Precambrian. So once again, hit Google, see what you can find. In terms of the Bass limestone, well, that one's relatively easy to date. You can just, once again, you go online, find a date for it. So in order to work out the difference between the Zoroaster granite and the Bass limestone, you're going to have to do a quick bit of research on Google. All right? But, and that's going to tell you, well, this is this old, what's the difference between the two in terms of their age? Okay? It'll tell you, for instance, this unconformity here, this layer of rock is this old, this layer of rock is this old, what's the difference in age? What's missing in terms of geologic time? And you're going to try and find the unconformity that has the most missing geologic time. Okay, so finally we have part C, and we are not going to do part C. I've tried part C in the past, and I'm afraid a lot of people have quite a bit of problems with these diagrams. They're very, very convoluted, very detailed, and people tend to find them quite difficult to work with. So, you know what, let's just save ourselves a lot of time and effort and not even go there. All right, guys, so give that a go. See if you can do it. I'm sure you'll be able to. If you can't do it, obviously, once again, you can ask me about it during office hours at the allotted time. All right, have a good day.